This is Chapter 4, Section 3. This is the second video. So, when you do binomial distributions, you have to account for both the success and the failure. So that's why there's a P and a Q in the variance formula and in the standard deviation formula, right? And it also, you only account for the successes in the mean because it's the mean number of successes, right? We don't care about failure at that point. Okay. Let's say we have 460 NFL teams, or NFL games, sorry, not that many teams obviously. And you take and the overtime you're going to take the ball based on the coin flip, and you're supposed to win this many games essentially. That's at least what the statistics say. So this is empirical type probability essentially. So the mean is n times p, right? So number of games is 460. The probability is, I'm sorry, what am I doing? That's supposed to be a multiply. Times 0.723, right? So that's going to give me 332.58 wins, essentially, right? Okay, so my variance, mu squared, right, will be n times p times q, right, which is 460 times 0.723, right? So if you do 1 minus that, you'd get what? 0.277, right? So you multiply that, you're going to get like 92.12446. Right? But you don't really need to calculate that, you know what I'm saying? We don't need this answer because we really want standard deviation, which is the square root of that, right? That's what we really want. So essentially, what you want to do is actually square root it. Don't round, then round again. That's the problem. You don't want to round twice, okay? So just don't bother calculating the decimal value of the first one. Just square root it, get your standard deviation. So that's about 9.5 wins, so 9.598 ... wins, essentially. Okay, so we want the range of one standard deviation, right? For the number of wins, right? Okay. Problem is not a whole number, so we'll say this is 333, you know what I'm saying? We'll kind of round that up to 333. Can't really get a partial win. And we'll say this is close to 10. That's close enough, right? So if I do one standard deviation, that's plus 10, right? So add 333s, that's 343, right? And if I subtract 10, that'd be what? 323? Okay. So one deviation is about that many wins, basically, you should expect out of 460 games. That is your expected value, right? That's your expected value of how many wins you should get, and that is your standard deviation, obviously. Okay? All right, so that is a decimal scenario, but you can certainly do fractional scenarios too, right? So let's look at this one. Let's look at a roulette one, right? So that's our decimal one. Roulette one is a fraction. Again, we're going to use American roulette. Okay? So U equals n times p, right? Mu, right, which is mean. So we're going to roll 95 spins. You're going to be there a while spinning, right? So there are 38 numbers on American roulette wheel, right? Because you think about it. Okay, what is there? There's 2 that are 0 and double 0, right? Then you have 18 and 18, right? So that's your red, that's your black, and this is your green, which is the 0 and the double 0 on the wheel, correct? So there are 18 winning numbers if you're betting on black, right? So that means you have 1,710 out of 38 that are going to be black, so that's 48 black spins, essentially. All right. So the standard deviation, right, is the n times p times q, which would be 95 times 18 out of 38, right? So losing is the red and the green, right? So that's the 20 out of 38. So if you multiply those through, you're going to get 34,200. over 38 times 38 is 1444. So again, you don't need the decimal value of that. It's better that you don't do that. So when you do the standard deviation, just square root that answer. Okay? So you don't want to round, you do not want to round twice. So 1444, right? So that's going to be approximately 4.86 repeating black spins. Okay, so we'll say this is 5, right? So if you add 5, you're going to get 50. If you subtract 5, you're going to get 40. So I should expect one deviation for this game to be between 40 and 50 black spins, essentially, right? So at the end of the day, we should expect 45 black spins if I play 95 times, right? And within one deviation is where typically most of the outcomes should fall. You know, although that's the expected one, and it's right. So again, I'm rounding the deviation to get that answer. Okay, so let's say we're going to use the binomial and PDF and CDF functions in my calculator or spreadsheet. So in the calculators, they tend to have a PDF and a CDF function. The computers don't do that for spreadsheets. They just use a false or a true to distinguish them, basically, because this is probability density function. This is cumulative density function. So all this is doing is accumulating or adding up all of them, right? That's why it's true. So the true means add them up. The false means don't add them up. So you're just doing one probability versus true. You're accumulating or you're adding up the probabilities, essentially. Okay, so let's say we have boxes of cereal have prizes in them, and 20% of them have a prize in them, correct? Okay. What's the probability of finding 2 with prizes if I buy 10 cereal boxes? So P of 2 is what I want to figure out, essentially. The probability of 2. Okay? All right. So the number of trials is 10, right? We want to have 2 successes. The probability of success is 20%, and the probability of failure is 80%. Every time I open a box, 80% failure, not getting a prize, correct? So I want to use the correct function. Well, this is only one probability, so I want to use this one right here, one probability, essentially. Okay, so let's go to the spreadsheet. So I'm going to open a new tab. Right, so this is the probability of 2, is essentially what we're going to do. Okay, all right, and we'll shove that to the right. Okay, so binomial dot distribution. You notice the pop-up says number. I want 2 prizes out of the number of trials, which is 10. The success rate probability is 20%. And then cumulative, right, is the last thing. I want to put false because I only want 2. If I put true, it's going to do 0, 1, and 2 because it's going to add left to right. And there's my probability, essentially. Okay? So, long story short, if I just do the false version, it just does one of them, which is the current one I'm on, essentially, right? Okay, let's look at the next one. Determine the probability you get 4 prizes or less, right? So I want P0 plus P1 plus P2 plus P3 plus P4, right? So this is not one probability. This is 5 probabilities, right? And the same thing is still true. N is 10. X is now a whole bunch of things, and the P and Q stay the same, right? We still have 20% and 80%, right? Except this is 0, 1, 2, 3, and 4. So we would have to do 5 individual probabilities, correct? Okay, so let's go to the spreadsheet. So we want to do P of 0 plus P of 1, right? Plus, I'm going to copy these just to save some time here. P of 2, P of 3, plus P of 4, right? Let's make this bigger. Equals, and we'll shove that to the right. Okay, so we're going to do the function to do this to save some time, right? Binomial dot distribution. Okay, I'm going to do 4, comma, 10, right? So number and trials, probability 20, 20%, and I'm going to put true this time. You're like, wait a minute, I wanted 0 through 4, why did I put 4? Because we're putting true, which means this is a cumulative function. So it's going to accumulate everything from 0 to 4, right? Because this works left to right. So this function does the direct method, right? We get the probability. So that's adding up all of these from 0 to 4, essentially, out of 10 trials, okay? So if we go back on our notes, okay, that's like doing this back here when we did direct versus indirect, right? Okay, it's doing the direct method, which is adding, but it's only adding left to right. That's how the function works, essentially, right? So this function essentially adds left to right. Okay, let's try a different version. So let's say we do this one here, where we want 5 prizes or more. So that's P of 5 plus P of 6 plus P of 7 plus P of 8 plus P of 9 plus P of 10. So again, this is not one probability. This is 6 probabilities, isn't it? Okay. All right. So everything else is the same, but here's the problem. Okay. We want copy paste. We want 5, 6, 7, 8, 9, P of 10. Okay, so if we do this function here, right, and we do the binomial distribution, okay, and we go to 10, comma, 10, comma, 20%, comma, true. The problem is I'm going to get an answer of 1. Let me shrink this down a little bit. Right? I'm going to get an answer of 1 because if I do 10, that's everything from 0 to 10. So 0 to 10 is everything. That's not what I want. That's not going to work. What I need to do is 4. Oh, wait a minute. That's still not the answer. Because if I do this, this is 0 to 4. So what I want to do is 1 minus that to get our answer. So what essentially did I just do? Right? I did 1 minus, right, brackets, right, and I take this here, I'm going to copy it, paste it, and then close bracket. That's essentially what I did. So either way, it's the same answer. Okay, whether I do it directly or indirectly, I get the same answer. But here's the thing. This function I'm doing only works left to right. That's the way it works. So it'll only do up to this number, essentially, right? Which is essentially why I'm forced to do it the indirect method to get this answer. Okay, so when you use the function in the spreadsheet, you have to think left to right and think directly versus indirectly to get the answer. Okay, so this one says calculate using the density function, verify manually in Excel. So this is the function, right? So manually in Excel is what we were doing before when we did this, right? When we actually went through and added them up. This is the manual method, right? And this is the density method, essentially, right? And there's 2 density functions, essentially, right? There is the PDF and the CDF. So PDF is just a single probability, right? You put false, you don't add them up. And CDF is a cumulative, which is you put true, which means you add them up left to right.